These are your class notes for learning how to calculate molarity. Molarity is just a unit for measuring concentration, which is how much solute you have dissolved in a solvent. Molarity is just simply the moles of solute per liter of solvent. So if that's what you were trying to calculate, you just simply have to divide the moles by the liter. Sometimes you're going to hear molarity be called a molar concentration, or if we say a molar solution, that also means molarity. If you take a look at this diagram below, you're going to notice that it has a drastic color change going from left to right. On the right-hand side is more what we would call a concentrated solution, which means it has a large amount of the solute dissolved in there. In this case, it's going to be the red food dye. If you notice on the left, it's very, very faint in color because there's only a small or minute amount of solute in there, which is the red food dye. So that's what it means by concentrated versus dilute. You have a lot of solute versus very little solute dissolved in the solution. One of the things that we are going to be doing is utilizing something I like to call triangles when we're calculating molarity. This is a really nice technique that I use to help keep myself organized, and it helps you solving the problems for molarity. So how this works is you cover up the variable you're looking for, and if you have the units that are on top of each other, they're going to be dividing. The top unit will be in the numerator and the bottom one will be in the denominator. If you cover up the unit you're looking for and the two known variables are next to each other, you are going to multiply them together. So for example, if I am looking for the mass, I would take my finger and cover up the mass, and you're going to notice how the molar mass and moles are next to each other. Since they're next to each other, you'll simply multiply these two to obtain the mass. Now, if I was looking for moles, for example, what I would do would be cover this up, okay, cover that up, and then notice how you're going to have mass over molar mass. So that's what I would do. I'd take the mass, I'd divide it by the molar mass to obtain the moles. We have one of these for molar mass, and we also have a triangle that we can use for molarity as well. So you can go ahead and copy those down on the top of your notes. All right, let's take a look at example number 1. So for example number 1, this says calculate the molar concentration of a 1.5 liter solution with 0.585 moles of solute. This is just a typical plug and chug problem where we're given the moles, okay, and we're also given the volume in liters. So to calculate this, the molarity is going to equal the number of moles per liter of solution. So for this problem, you take the 0.585 moles, and we're just going to divide that by the 1.50 liters. Now, just as a friendly reminder, if you have a mole on top and a liter in the bottom, just know that that means molarity, okay? So this answer is going to end up with 3 significant figures. You take 0.585 divided by 1.50 liters, and you end up with an answer of 0.39. This is what your calculator will give you. Now, you have to be smarter than your calculator. You know that there has to be a third significant figure. So what we have to do is we have to add that 0 in there. So we know that this is going to be 0.39. Oh, gosh. Let me do that. 0.390 moles. Okay, I'm not going to box anymore. All right, let's take a look at example number 2. Now, example number 2 is a problem where I am going to introduce both of the triangles. The reason why is if you have any problem that involves grams or the mass term, it helps you with keeping track of what to do and what to solve for. So in this problem, it reads 15.0 grams of sodium chloride is dissolved in enough water to bring the water level to 200.0 milliliters. Calculate the molarity of the solution. All right, so how I start these problems is I like to look at all of the information that's given. I like to check it off on my boxes. So for example, it says I have 15.0 grams, so that means I have mass. If you also know what the chemical is, just know you also have the molar mass. We just have to calculate it real quick. Just act like you know it. It's just like in the background information. So you have it, you just have to get it real quick. We also have right here the volume. Now the volume is in milliliters, so I'm just going to say we have it. we can get it real quick. We just have to simply convert it and change it to liters. Now, what we are ultimately looking for is right here. We are ultimately looking for the molarity. So in order to find the molarity, we need to get moles. Now, if you look right here, if I take the mass, I divide it by the molar mass, I will get moles. And what I can do is take that moles and plug it in right here. And once I have this moles, I divide it by the volume to get the molarity, because this is the same. Okay, those are going to be the same moles. So that's what's nice about this, is the mole term will translate between the triangles. All right, so let's go ahead and let's start here. The first thing we're going to do is let's get the molar mass of sodium chloride. So the molar mass of sodium chloride, you have sodium, which is 23.0 grams per mole, it's its atomic mass, and you also have chlorine, which is 35.5. When you add those together, you get 58.5 grams per mole. Okay, so that is my molar mass. Let's go ahead and let's change this volume into liters. I'll do that on the side over here. Just remember the relationship is there's 1,000 milliliters in 1 liter. Okay, so if I have 200.0 milliliters, I have 1 liter on top, 1,000 milliliters on the bottom. That will cancel out, and I will be left with 0.2, and all these zeros are significant. So 0.2000 liters. Okay. All right, let's go ahead and let's solve for the moles first. So for moles, it's going to equal the mass divided by molar mass. So we take the 15.0 grams, and you divide that by the 58.5 grams per mole. Okay, the grams units will cancel out. You'll have 1 over a mole, which actually is a mole. And for the moles, you end up with, let's see, 0.256 moles of sodium chloride. Now, to calculate the molarity, that is the moles divided by the liter of solution. So we already calculated the moles right here. We have the liters right there, and all we have to do is simply divide those. So we take the 0.256 moles, and you divide that by the 0.2000 liters. And remember, if you have a mole over a liter, that is molarity. So my answer here is going to be 1.28 molar. Let's take a look at example number 3. Now, example number 3 is kind of a special problem because this is what you guys are going to be doing in your molarity lab. So make sure you pay special note or special attention to this because this is the same math that's involved in that process. So for example 3, it says how many grams of calcium hydroxide are needed to make 100 milliliters of a 0.250 molar solution. First of all, we need to know what the formula for calcium hydroxide is. So it's calcium Ca with a +2, hydroxide is OH with a -1. When you cross your charges, you get Ca in parentheses, OH parentheses 2. Okay. Since we're looking for how many grams, I know I'm going to have to find molar mass. Let's just get the molar mass right away. So for the molar mass for this, you have, let's see, calcium is 40.1. There's 2 oxygens, so that's 16 plus 16 plus hydrogen is 2.02 for both hydrogens. So we're looking at about 74.1 grams per mole. Okay. Let's go ahead and let's see what we have in our problem. So we're looking for mass right here. All right, we're looking for the mass. We know the molar mass, so I just calculated that. We know molarity, and we know the volume. Okay, even though it's in milliliters, I can convert that real quick, and we can just do that. Simply, you just divide it by 1,000. So this is going to be 0.1000 liters. Okay, so just as a friendly reminder, that's what you do to get milliliters turned to liters. Just divide it by 1,000. Okay, so what do you think the game plan is here? Well, in order to find mass, we need to get moles. But look right here. If I take the molarity times the volume in liters, I get moles. So once I get moles, I'm going to plug it in, and then I can multiply these two together to get the mass. All right, so let's go ahead and let's do that. So to calculate moles first, so moles is going to equal the molarity times the volume in liters, which is going to be the 0.250 molar solution times the 0.1000 liters. Now, just to show you how the units work, remember molarity is moles per liter, so we're taking a moles per liter times a liter, so that's how you get to the mole term. So we take that and we get 0.0250 moles. Okay. Now to get mass, okay, so calculate the mass, which is ultimately what we are solving for. The mass is going to equal the molar mass of calcium hydroxide multiplied by the number of moles. So that is going to be the 74.1 grams per mole. And we're going to multiply that by the number of moles, which is 0.0250 moles. Okay, the moles will cancel out and we're left with the mass. And the mass for this is going to be 1.85 grams of calcium hydroxide. Okay, and this is my final answer. All right, one of the things that we will be having to do is learning how to prepare a molar solution. So the first thing you need to know is what is the concentration and how much of that solution you need. So that means we have to find the mass of the solute first, because remember, a lot of the solute comes as a solid, so we have to dissolve it. So the first thing we need to do is mass out the calculated amount of solute that we need to prepare a solution. Then what we're going to do is we're going to use something that's called a volumetric flask, and we are going to put our dissolved solute in here. So here is the solute, and what you should notice about this is a volumetric flask is calibrated to contain a very precise volume, and there's going to be a mark on it. So you can see right here, come on, go away. There is this mark right, okay, well, there's a mark right there. That is the 1 liter mark. So what you do is once it's all dissolved, and a lot of times you have to shake this, you can stir this, you can agitate it, do one of those factors that we talked about how to dissolve a solid. Once it's all dissolved, then we're going to dilute it by adding water and make sure the meniscus is right on that line right there. Okay, and that's how you would make a very precise 1 liter solution of whatever concentration you need. So we're going to take a look at how we prepare a solution, like what I would do in a lab for our labs that we do. And so here's just another demonstration of that. So in the first picture over here, you have a little bit of water. You put your dissolved solid, or you put your solid solutes in here. You swirl to dissolve, and then what's really nice about this right here is sometimes I like to do this. I usually use a wash bottle. You can take the lid off and start adding water, but then once it starts to go up the neck right here, so once you start having water go in the neck, then it's really nice to use a wash bottle where you can be really precise and control how much water you have so you don't overshoot the meniscus, so you go over that 1 liter mark. Okay, real quick, before we get to our last example, number 4, let's talk about how we represent concentration. Sometimes if you see a chemical that's in brackets, that means molarity. So for example, if you see NaCl in brackets, it means that's the concentration of sodium chloride. So in this example, it would be the concentration of sodium chloride is a 0.876 molar. That means how many moles per liter you have 0.876 moles per every 1 liter of solution. This is going to be really useful or really handy for us to know this when we get into acids and bases. Because in acids and bases, what we do is when we measure pH, we're looking at the concentration of the hydrogen ions in solution. So if you notice what this means, if you know that's a hydrogen ion, if you know it's in brackets, it's the molarity of the hydrogen ion. All right, here comes our last example. So what we are going to do is we're going to be preparing a solution. So it says for lab, 1.00 liters of a 0.500 molar potassium hydroxide solution is needed. indicate the steps and math involved to prepare the solution. So notice right here, this is what the potassium hydroxide looks like. It is solid pellets, and what we have to do is figure out how much to add. So we are going to use an electronic balance right here and to dissolve it in our volumetric flask. So let's take a look at this math involved. So this is the same as example number 3, stepwise. So the first thing we need to do is make sure we know what the molar mass of potassium hydroxide is, and it is 56.1 grams per mole. What we're going to do next is calculate the number of moles. So you take the molarity of the solution and you multiply it by the volume. So this is actually easy. So it's 0.5 times 1, which is 0.5 moles. So that's how many moles we're looking at. The next thing we're going to do is take the molar mass and multiply it by moles to get how much of the solutes we need to dissolve. So this number right here is how much solute we need. Okay, so let's take a look at the steps now for what we would actually do. So the first step is let's mass out 28.1 grams of potassium hydroxide on an electronic balance, and let's place it in the 1 liter volumetric flask. What we're going to do next is add about 300 to 400 milliliters of water. So it's somewhere around this region in the bottom of this bulb, in the lower region part of it. You're going to fill it up with water, and you're going to dissolve it. Now this is the step where you would actually add heat, so you can use a magnetic stir bar, you can put on a hot plate that can stir, and just remember with that combination of being heated and agitation or swirling it or mixing it to dissolve, it should dissolve the solid. If not, you might have to add a little bit more heat or a little bit more water to get it to fully dissolve. Just think about the solubility curves when you're doing this. The next thing you're going to do is once the solid is all dissolved, you're going to add the remaining water, fill it up, and make sure that meniscus hits that 1 liter mark. Okay? And then you're almost done. Now the one thing I do want to mention though is this is very important to do this. What happens here is notice that there's a color change here. So this down here is really dark. Okay, so this would be like very, very concentrated down here. Up here, notice how it's a lot lighter color. So this is a little bit more diluted. So what we have to do is you're going to place a topper on here. It's a glass topper, and we are going to invert this several times. That means just tip it upside down and flip it back. Tip it upside down and flip it back, and do that about 5 or 6 times. What that'll do is help to thoroughly mix the solution so it's more evenly distributed throughout. And those are the steps for preparing the solution.